All right, listen up, you guys. Now, we're going to go through and actually classify quadrilaterals by sides, slopes, and diagonals. Okay, we're going to reference back in our notes a couple times for a couple different things here. So, for this one right here, we're going to using diagonal determine if this is a rectangle or not. Now, first thing, okay, we're going to figure out the different sides. So we have our points right here on our graph already. Okay, on a couple of these, you're going to have to actually sketch your own and actually try to use your coordinates there to find some of your information. Okay, so I'm going to change this up a little bit. Now for EG, we're going to find the distance of EG. So the formula that we use is slightly different. Okay, so from E to G, now, we use the distance formula. So EG D is equal to the square root of, now, in between E and G, what is delta X?
7.
7. So that's going to be 7 squared plus, what is delta Y? 1, right? Yes?
Yeah.
So that's 1 squared. So D is equal to the square root of 49 plus 1 is 50. So D is about, what's that going to be? 7.1? I think so. Yes?
Yeah.
Okay. Now, just giving that much information, I know the length of this one here. Now let's do the same thing for FH. FH is from here to here. So, again, D is equal to square root. Now, we're doing F to H. So, from F to H, what is my delta X? 5, very good. 5 squared. Plus, what is my delta Y? 5, right? 5 squared. So, D is equal to the square root of 25 plus 25 is 50. So D is about 7.1. Okay, so we're going to see if this one is going to be a rectangle. Now, if the diagonals are the same, let's look back. I'm going to back a couple pages. Okay. So, is it a rectangle? So, I'm going to my notes here. I'm going to pull this one out. This one's in 77 for this. Okay. Right here. It says, for rectangles, diagonals are congruent. Okay. So, are these congruent? Yes, they are. So, is this a rectangle? Yes, it is a rectangle. So, I'm going to come over here and say, yes, it's a rectangle. Now, the next. So, right here, we're going to try and figure out, determine if EFGH is a square. Okay. Now, I'm gonna make it a little bit simpler than this. Okay. We don't actually have to figure out the slopes to figure out these things. Now, if it's a rectangle, we know the diagonals are congruent. But what about the sides?
It's,
Are all of them the same?
no.
No, they're not all the same, are they? So this is going to be a lot easier for you guys to do, because in a square, all the sides are the same, aren't they? Because a square has all properties of a rhombus, and a rhombus has 4 congruent sides. So we could easily find the distance. So instead of doing the slopes, let's try and figure out if all the sides are the same. So let's figure out for EF. So EF, so my distance is equal to the square root. So we're figuring out what this one is here, right? So EF from here to here. So what is my delta X?
Two.
From -4 to -3.
One.
That's just 1, right? Delta X is how far they're apart, so that's 1. What is my delta Y?
Three.
It is going to be 3. Very good. So that's going to be D is equal to the square root of 1 plus 9 is 10. Square root of 10, right? Okay. So since I don't know, I don't need to actually approximate from this one to go further. I just need to know if these two are the same. So I'm going to get rid of this part because finding the slopes is a lot more work. Now, this one right here, E to H, is going to tell me if it's the same distance as EF, it's going to be a square. If it's not the same distance, then it's going to be a rectangle, right? Okay, so let's see. So from E to H. Now from E to H, what is my delta X? 6 squared. Plus, what is my Y squared?
2 squared.
2 squared. So it's 36 plus 4.
40.
Now, looking at these two things right here. These are not the same, right?
No.
So this is
Not a square.
not a square.
No.
Oh, there's not. Not a square. That should be pretty straightforward, right? That's the easiest way to do this. Alright, so let's go with this one. It says, prove or disprove each statement about the quadrilateral determined by the points. So we're going to put the points on here now. So let's see. 2, -3, 1, 2, 1, 2, 3. -4, 0. -2, 4. 4. And 4, 1. 1, 2, 4. Up 1 right here. Did I put it in the wrong spot?
Yeah.
Yes, I did, didn't I?
It's
Dang it.
-2.
-2. 1, 2, 1, 2, 3, 4. There we go. Ah, man, I am horrible at this.
Same.
Who corrected me on that one?
Me.
Me? I don't have me in this class.
It was other Briss.
It was Briss.
I corrected you so many times and I didn't get candy for it.
Would you like some candy for it?
I really would.
You know what? I made enough of mistakes, so I will pay for my crime.
Chris, there's no one named Chris in the
Okay. Yes. All right. So it says right here. So we're going to prove or disprove. Diagonals of this are congruent. Diagonals of this are congruent. So that means we need to draw a diagonal. Okay. Make sure we label this. So 2, -3. This is Q. -4, 0 is R. -2, 4 is S. And T is 4, 1. There you go. Alright, so let's do the diagonals. So again, so SQ. So from S to Q.
It's okay, you can put it right over.
Oh, I'm sorry, there we go. D is equal to the square root of, now we're doing S to Q. So here's S and here's Q. What is my delta X?
4.
4, very good.
4 squared.
Plus, what is my delta Y?
7.
7. So it's going to be 16 plus 49.
65.
Okay, let's just leave it at that. We don't need to approximate it from here. We just need to see if they're the same. RT. So now we're going to find the length of RT. So it's going to be my distance is equal to square root. So R to T. What is my delta X?
8 squared.
8. Very good. Squared plus delta Y. 1 squared. So that's going to be square root. That's 64 plus 1. So the diagonals are the same. Okay. So if the diagonals are the same, I could say it's a what? It is a rectangle, right? So yes, it's a rectangle. So this is yes here. It is a rectangle there. Find the slope of each side of the quadrilateral. Now we're going to do the slope here. Okay? We didn't have to do it on the previous one because doing the distance is easier to prove or disprove. Now it's just asking for the slope of the sides. Now, if you guys remember, we did slope recently, where slope is m is equal to y2 minus y1 over x2 minus x1. Yes?
Wait, what's M?
What's what?
What's M?
M is the slope. M stands for the slope.
Oh, yeah.
M is the abbreviation of slope. Yes, you may. Alright, so we have that much information. So now let's go through and do this for RS. So now RS, can you guys see it up there? No. There it is. Okay. So RS. So let's call S my second one. So RS, okay, so it's going to be Y2. So it's going to be 4 minus 0 over -2 minus -4. So it's going to give me 4 over, change that to plus, minus the negative becomes plus 2, so my slope is 2 over 1. So I did that one. Okay. Now the one that's supposed to be parallel to that is over here, QT, right? Let's do QT next. So let's have T be my second one. So it's going to be 1 minus -3 over 4 minus 2. Very good. So minus negatives give me a plus 4 over 2, which is 2 over 1. Are these two the same? Is this and this the same? Alright, class. If the slopes are the same, what do I know? They are what? Parallel. Slopes are the same, they will be parallel. So these are parallel now. Now we have to check the other ones. ST. ST. So T is my second one here. So that's 1 minus 4 over 4 minus -2. That's going to give me -3 over, what's that, plus 6, -1/2. Okay? Did I lose anyone on the math?
No.
So there's ST, and what's the last one I have to do? RQ, QR, right? So RQ. So Q's the second one. So it's going to be -3 minus 0 over 2 minus -4. So that's going to give me -3 over plus. So it's going to be 6, -1/2. Are these two the same?
Yes.
So those two are the same, so opposite sides are parallel. And these two opposite sides are parallel. So in this case, are all opposite sides parallel?
Yeah.
Yes, they are. So this has to be a rectangle. Opposite sides are parallel and the diagonals are congruent. Okay? So, prove or disprove this next one. Determined by the points here, is it a parallelogram? So let's put the points. A is at 4, 4, 1, 2, 3, 4, 1, 2, 3, 4. B is at 3, 1. C is at -2, -1. And D is at -1, 2.
What kind of shape is this?
I'll let you guess. Very good. Parallelogram. It's supposed to be, but we have to check to see if it is going to be. Okay. What property is a parallelogram that I can automatically use?
Huh? That is? Parallel opposites?
Opposite sides are going to be parallel. That's what I need, right? Opposite sides are going to be parallel. Okay, so let's do that. So opposite sides are going to be parallel, so let's do the same math that we just did. So let's start off with, let's go CD and AB. So CD, so if it's CD, D is the second one, 2 minus -1 over -1 minus -2 plus plus 3 over plus plus 1. So it's 3 over 1. There's CD. Now let's do the next one. Which one should be parallel to CD? AB. Let's do AB. So B is my second one. So it should be 1 minus 4 over 3 minus 4. So it's going to give me -3 over -1. So two negatives make positive. 3 over 1. Very good. So now these two right here tell me what?
They're congruent.
They're going to be
Parallel.
parallel. Very good. Those two are parallel. Okay, next two. Let's do DA. DA. A is the second one. So it's going to be 4 minus 2 over 4 minus -1. So that's going to give me, right here, this is going to give me 2 over 5. Now, let's do the last one. The last one would be what?
CB.
CB. So B is my second one, so it's 1 minus -1 over 3 minus -2. So plus plus 2 over 5. Are these the same?
Yes.
Now they're parallel. Yes? Okay, good. They're parallel. Parallel, so opposite sides are parallel. So that's good. So that means it's going to be at least a parallelogram, right? Now, we're going to compare these two. Now, if you remember the notes the other day, for it to be perpendicular, so for perpendicular, opposite sides, okay, right, okay, so right here, the slopes, so for right here, these slopes have to be opposite and reciprocal. So if I take this, 3 over 1, what's the opposite of a positive? Negative. So what is the reciprocal of 3 over 1?
-3 over oh.
-1/3, right?
Oh.
So, are these two slopes perpendicular? Does it make a right angle? Is this this?
No.
And you'd say no, right? These two are not the same. So it's not going to be perpendicular. It's not going to be perpendicular, so this is not going to be a right angle. So this is only a parallelogram. This is only going to be a parallelogram. It's not going to be the rectangle. Questions, concerns, complaints? All right, we have like 1 minute.